show that. In contrast, what we see in the exposed animal is no decrease in the amygdala, and these are data that will be submitted for publication soon, but virtual disappearance of the binding in the brainstem compared with the unexposed animal. And the question is, are these biologically and statistically significant observations? So in this model, to be brief, we've looked at the between subject factor, which is exposure, the effective exposure, the repeated outcome measure, which is the binding of this molecule to the brainstem, and the time to acquisition of the reflexes. Is there an interaction between these various elements? And the answer is yes. There was, first of all, an overall effect of exposure on binding, so exposure to the vaccine influenced the binding of this molecule to its receptors in the brain. And we found significant interactions between the exposure, the binding, and the time to acquisition of the reflexes, and we found this virtually across the board for all reflexes. And the delayed acquisition in this model was always, again, to the detriment of the exposed group. So this is a systematic difference. It is not a random finding. So in summary, volume-adjusted diprenorphine binding, this is the receptor molecule here, to the brainstem shows that opioidergic systems are affected by vaccine exposure. And we see an interaction between the change in binding and exposure, which is reflected in a difference in the time to acquisition of the reflexes. So, vaccines induce altered brainstem function with delayed acquisition of survival reflexes, altered brainstem opioid receptor functioning, and this is a novel and important finding, the significance of which we are not certain at the moment, but clearly requires replication and further analysis. And again, just to repeat, it does not discriminate between what is causing this. Is it thimerosal? Is it something else in the vaccine? Is it the vaccine as a whole? And therefore, it doesn't clearly exonerate the neonatal hepatitis B vaccine as yet. Now, I'm going to just talk about what I believe may be the significance of this, and I'm not a neurologist or a neurophysiologist. I'm a gastroenterologist, so please forgive me. But I think that there are some very, very important clues in this for what may be going on. And I think clues also emerge from our historical knowledge of autism, which might predict the relevance of these findings. It has been known for some time, it's certainly not novel, that the brainstem appears to play a very important role in the evolution of autism. You may well be aware, and my experience of this has come exclusively from parents, that apart from all the behavioral problems that children experience, there are other elements which don't fall under DSM. You don't find in ICD-10 in the description of autism, but which are a recurring theme in the clinic. And those are abnormalities of temperature regulation. The child will go out on a cold day with no clothes on, or on a hot day they will dress up. They seem to have fundamental problems with either perception or regulation of temperature. Intestinal motility, constipation, acid reflux or reflux into the esophagus are major problems that we have to deal with in the clinic and are some of the most refractory problems, the most difficult ones to deal with. It's been observed by Carolee Horvath and others, including Tim Bowie at Harvard, that there is a diminished pancreatic secretion in these children. That's the secretory response of the pancreas to administration of secretin in many children is greatly exaggerated compared to controls, and this are developmentally normal children. And this may suggest that there is chronic understimulation of the pancreas, and that when you do stimulate it appropriately, then it responds with a huge output. There are sleep problems, there are stress-associated problems, and all of these things suggest that there is something more going on. These are very, very important clues, perhaps even more important, I believe, than the behavioral problems, which are a downstream manifestation. So, they tend to suggest that there is an autonomic dysfunction, that part of the brain, or those parts of the brain that control the fight or flight responses, the autonomic nervous system, the sympathetic and parasympathetic nervous system that you will have heard about, are of fundamental importance. And a lot of the original work on the brainstem was done by Patricia Rodier. And Patricia Rodier, working specifically with the drug sodium valproate, the anti-seizure medication taken by mothers during pregnancy, the observation that the outcome of some of those pregnancies with a child with autism led to the idea that exposure to this drug at the time of neural tube closure in the embryo, in the fetus, was a major determinant of autism.